Hello, today we would like to show our mini project. So let's get started. To the overview, we like to create drum machines that lights an LED up and play a sound through a buzzer, which has the buttons is like hitting a real drum. It also has preset buttons to change the different beat patterns, and we have two knobs. The one knob is control the frequency of the beats, and another one is control the speed, like to the slow or fast. So our inspiration is by the Roland TR-808. It's a famous retro drum in the 80s. It played a big role in sound industries like hip hop, electronic, and pop music. But the challenge is, unlike the TR-808, which use analog circuit to generate a drum sound, the Arduino that we use is limited by only producing square wave that using digital output, so which is what we need to adapt it. So to adapt it for the better, we change the frequency to create a different tone, and we adjust the playback speed to vary the rhythms, and we have add LED visual that match the sound for better visual or display feedback, and we use the preset patterns for more dynamic and fun experience. Okay, this is the system components we not use much. First one is the main things is Arduino Uno boards, and we use breadboard to connect the all components together, and use jumper wire to connect all together also, and use buzzer to create a sound, and LEDs with resistor to provide the lights up, and potentiometer or knobs we use to adjust the frequency and speed, and the buttons used for preset and the drum. So the methods, first we connect the Arduino with the computer using 5V, and then we connect all the components together, and then we coding with Arduino IDE. And the coding part I will let my friend to explain to you.
Okay, let's go to the main part of this code. At the beginning, we define all input buttons and output LEDs. Each drum pads and mode has a corresponding button and LED, such as the kick button here and the kick LED here. We also use analog pin for potentiometer to control pitch and speed, like this one. For the system variable, we declare variable to check button, state, and effect modes, including facts like kick paste here and the effect mode over here. These help manage the logics when buttons are pasted. For the setup functions, in the setup functions, we initiate all pins using the pin mode here and see the random number generator. This ensures all components are ready and responsive. For the main loop, the loop function takes the state of all drum buttons using a helper function, like I take button state here. This function handles debouncing, play sounds, and light up LED when buttons are pasted. Okay, here. For the effects and preset control, the effect buttons toggle effect mode if the effects are turned off. This clear the sound view, and the preset button switch between 10 sound styles, allowing each pad to behave differently per preset. For the sound system functions, we have a few functions to manage this, like the update sounds. These functions is crucial for playing a sequence of notes like a pitch drop and an arpeggio. For the random effect logics, the random buttons toggle the random effects mode when active. It's either play random tones or fixed tone at random interval, depending on the mode. This managed by the start random effects and the handle random effects. For the sound generator, each pad snare, pad 1, pad 2, pad 3 has its own pay functions. These functions queued up tone sequence using the method like the Q sounds, Q pitch drops, and the Q arpeggio. This module approach makes the drum sound diverse and programmable. Okay, for the last one, sound helper functions. These drum sound functions use a few helper functions to create the sound effects, like this one. Okay, in conclusions, these idle drum machine synthesizers combine the interactive hardware with the creative audio algorithms to produce a flexible, hand-on electronic music experiment. It's ideal for learning sound synthesis, digital logics, and the hardware interface. Thank you for your listening.
Okay, this is our projects. This project is divided into three main parts. The first part is the drum machines, and the second part is the random sequencer, and the third one is the buzzer. I use the module buzzer put inside the tissue core to make the sounds a bit wider. To use these projects, we have to know how each section works first. For the first part is the drum machine. As you can see, each button can create its own unique sounds, which I set this button to be a kick sound. The second one is the snare, and the third one is pad 1. The fourth one is pad 2, and the last one is pad 3. And the most interesting part of this section is the preset sounds. If you click this button, the sound is totally different. Which I set this preset to have around 9 set of sounds. I will show you. If we click this button until 10 times, it will turn back to the first preset. Okay. For the second part is the sequencer, the random sequencer. If we click this button, nothing happened because we haven't activated this yet. To activate this function, we have to press this button. The light is on. Okay. If we click this button again, it will create the random sounds. In these sections, we have two potentiometer. The first one is if we turn it up, the sounds or tones is going to be higher. Oh, it's a bit high. Okay. If we turn it down, the tone is going to be lower. And the second potentiometer is the delay. If we turn it up, the sequence is going to be faster. If we turn it down, it's going to be slower. Okay, I will set it like right here. Okay. And you also can still use this drum machine as well while the sequence is activated. And we also have the other secret functions. If we place this button, the sounds is gonna be stable. If we place this button again, it's gonna turn back to the random mode. To stop these functions, we have to deactivate here. Okay, it's turned back to normal. This is all for our instructions.